Okay, in this video, I'm going to show you how to simplify a radical expression such as this one, cube root of 64 multiplying x to the 12 multiplying y to the 9, okay? And as you can see at the beginning of the video, I included a list of perfect cubes numbers, okay? And I'll go into details in the middle of this video as I'm walking through this problem, okay? Now, the first step I'm going to do is that I'm going to rewrite this expression into the fractional exponent form of this root, okay? So that's going to give me 64 multiplying x raised to the 12 multiplying y to the 9, and all of this is raised to the 1 over 3, okay? Now, of course, you don't have to write it in fractional exponent form, but if you are more comfortable with that, then feel free to go ahead and do it, okay? At this step, if you take a look at the inside of the parentheses, you can see that there is only multiplication. And because there is only multiplication, we get to use one of the laws of exponents, and we distribute the outside exponent 1 over 3 over here to each of the one on the inside, okay? So that means we get to take 1 over 3, we distribute it to the invisible 1 of the number 64 here, and then to the 12 of the x, and then to the 9 of the y, okay? So that means I'm going to have 64 raised to the 1 times 1 over 3 multiply x raised to the 12 times 1 over 3, and then multiply y raised to the 9 times 1 over 3. Okay, so hopefully that's clear for you guys. Now, of course, whole numbers multiply fractions means you specifically take the whole number and you multiply the numerator while you keep the denominator the same. And you do the same thing for these two, okay? So over here, you got 1 times 1 over 3. And over here, you got 12 times 1 over 3. And over here, you got 9 times 1 over 3, okay? Of course, easy algebra, 1 times 1 over 3, it's just 1 over 3. 12 times 1 is 12, divided by 3 is 4, so you got x to the 4. 9 times 1 is 9, divided by 3, it's just 3, okay? Now, at this step, we can see that x to the 4th and y to the 3 are all done. So we don't have to touch them anymore. But what we can do is we can do something with a 64 raised to the 1/3. Now, what is 64 raised to the 1/3? Well, if it is more convenient to rewrite the fractional exponent 1 over 3 back to its equivalent root form, we would have the third root of 64. And of course, we got to bring everything else down. Oops. Have to bring down everything else, okay? Now, what is a third root of 64? Well, if you recall the first few seconds of this video, 64 is actually a perfect cube numbers. Because what happened is that cube root of 64, which is the same as 64 raised to the 1/3, is going to be equal to a smaller integer, 4. And why is it equal to 4? Well, if you take 4 and you multiply itself 3 times, hence the denominator of the fractional exponent here, and hence the third roots over here, 4 multiplying itself 3 times is going to give you back 64. So always remember that in fractional exponent, the denominator of the fractional exponent indicates how many times that specific small integer has to multiply itself in order for you to get back the radicand, which is 64 in this case specifically. Okay, so so for example, if you have like cube root of 8, well, cube root of 8 is going to be equal to 2 because 2 had to multiply itself 3 times like this. It's going to give you back the radicand 8. Okay, and of course another example could be 125. So third root of 125 is equal to 5 because 5 times 5 times 5, 3 times, it's going to give you back 125. Okay, and of course the same thing can be said for the 4th root, the 5th root, 10th root, so and so. Okay, meaning that, for example, in the 5th root, the 5th root of a number has to be equal to an integer such that when that integer multiplies itself 5 times, you will get back the radicand of that 5th root. Okay, so make sure you guys keep that in mind. And of course the result when you multiply a specific integer by itself a finite amount of times, actually no, I should say it. A root of a number has to be equal to an integer, not decimal, not fraction, so and so. Okay, so it has to be an integer. So that means, again, that smaller integer has to multiply itself a finite amount of times, depending on what type of roots that you have, in order to get back the radicand. Okay. Okay, back to what I was saying. So anyway, so third roots of 64 is actually going to be equal to 4. Because just like on the right hand side, 4 times 4 times 4 is going to give you back the radicand 64. Okay, you can see it there, but there you go. So that means what? That means we are going to have 4 times x to the 4 times y to the 3rd. But hey, guess what? We are done because we cannot simplify this anymore. So that means cube root of 64 times x to the 12 times y to the 9 is going to be simplified down to be 4 times x to the 4 times y to the 3rd. And that is it. Thank you for watching, you guys. Okay, one more thing before I go. Earlier I said that if inside the parentheses you only have multiplication, then you get to distribute the outside exponent to each every one on the inside. Okay. However, to be more flexible and to correct what I said earlier, if you have multiplication and or division, then it is okay to do that distribution. Okay. And yeah, I just want to fix that. Thank you for watching, you guys.